Hi everyone. Sorry I can't be in school today, but I wanted to put this video together so we could pick up where we left off in class. I'm not going to go over, what is already in your notes, okay? We're really going to take it from our last class, where we were in our last class, and go forward. Okay, what did we do in our last class? I introduced you to what this number is in chemistry. It's called the mole. Okay, the mole is it's Latin for lump of stuff, because when early chemists were working with moles, they didn't really know how many atoms they were working with. But later on, we found out what the number of atoms is. One mole of atoms, or 1 mole of molecules, or 1 mole of anything, basketballs or donuts, is 600 sextillion. Okay, and it could be anything, just like a dozen equals 12, or one couple equals 2, or one trio equals 3. Remember, when I'm talking about moles, I'm talking about a number of things. And what do we count using moles? We count atoms and molecules. Okay? 600 sextillion. Another way of writing that is 6 times 10 to the 23rd power. That's 6 with 23 zeros after it. All right, so there's 6. There's a 6 with 23 zeros after it. That's 600 sextillion. You would agree with me that that's an unbelievably large number. But from the last time we were together, we found that 1 gram of hydrogen atoms is 1 mole of hydrogen. And we found that 16 grams of oxygen is 1 mole. And that's hydrogen, that's oxygen. 20 grams of neon is 1 mole of neon. Okay? So this is where we left off last time. We found that we can count atoms by weighing out the material. All right, so I wrote this out to really emphasize this. We're counting atoms and we're counting molecules by weighing out the material. Okay, all we need to know is this. Okay, in order to do this, we need to know the molar mass. I'm going to write that down. All right, so in order to do this, we need to know the molar mass of a substance, the mass of 1 mole of a substance. So write that down. The mass of 1 mole of a substance is the molar mass. The molar mass for hydrogen is 1 gram. The molar mass for oxygen is 16 grams. The molar mass for neon is 20 grams. And now I'm going to go to the periodic table and show you where you will find the molar masses for all of the elements. Okay, so here is the periodic table, and I showed you the molar mass for hydrogen. There it is. Here. The molar mass for hydrogen, here, let's do that, is 1 gram for every mole. The molar mass for helium, it's over here, He, helium, 4 grams for every mole. Sodium, 23 grams. 1 mole is 23 grams for sodium. Carbon, 12 grams for 1 mole of carbon. 16 grams is 1 mole of oxygen. 14 grams is 1 mole of nitrogen. 20 grams is 1 mole of neon. Okay, so in order to find the molar mass on the periodic table, we always look at this number. this number, by the way, I'll just use sodium as an example, is called the atomic mass. Okay? When you take the atomic mass and just call it grams, that represents 1 mole of atoms for that element. Okay? All right, I just wrote this out and I'm going to say it again. When you look at the atomic mass for an element on the periodic table and just churn that number into grams, like for instance, for sodium, I'm looking at here. Sodium is right here. I'm looking at sodium and I'm rounding that number to 23. Okay? 23 grams of sodium is 1 mole of atoms of sodium. The atomic mass, when you express it in grams, represents 1 mole of atoms of that element. All right, so now you're probably wondering, how do we round these numbers? I mean, let's take a look at iron, for instance. Here's iron, by the way. Iron, right there. Okay? The molar mass for iron, you're looking at that number and you're saying, well, it's 55.845. My rule of thumb, I guess, for the molar masses for these elements would be to round to the tenths place. So for iron there, I would call that 55.8. That would be rounded to the tenths place. What about another one? Let's say, let's go to chlorine over here. Okay, chlorine is way over here. Okay, chlorine, I would say, let's not call it 35.453 grams. We could just go with 35.5. Okay, so my rule of thumb is to always express molar masses to the tenths place. Here's oxygen, by the way. All right. If I rounded this to the tenths place, that would be 16.0. Or nitrogen would be 14.0. Or carbon would be 12.0. Okay? So on the worksheet that you're going to be working on, you're going to be finding the molar masses for the elements by looking at the periodic table. Just as a side note, you're never going to memorize any of these numbers. You will always be given the periodic table. All right? Chemistry is not about memorizing the periodic table. It's about using the periodic table as a tool. Okay? Okay, so I just showed you how to find the molar masses for elements on the periodic table. So let's take a minute now. I'm going to give you 4 different elements, and you write down the molar mass, and then I'll show you the answers. Okay, so this is going to be a self-test, and then you'll be ready to go to the worksheet. All right, so see if you can find lithium and magnesium and aluminum and xenon on the periodic table, and write in your notes or somewhere what the molar mass is. And then I'm going to give you the molar mass, and you can match your answer against my answer. Okay? So remember, write your molar masses to the tenths place. Okay? So stop the video now and really work through this on your own. Okay? And then you can go to the worksheet. I'll write down the answers in a minute. Okay, here are the answers. You'll notice that I wrote these answers to the tenths place. Please don't round them too much. If you round these numbers too much, you're going to mess up your answers. And, because as we go forward in chemistry, we're going to use molar masses a lot. Okay, so this is where we're introducing this, but trust me, this is just going to be just part of our everyday life in chemistry from now on. So I'm going to leave you to work on the worksheet then, that is for your homework, and and good luck.